from the last class that we discussed on memory management. And if you can remember, on memory management, we discussed the following things. So let me use the PowerPoint to define what we discussed. So what we discussed, we discussed on activities of an OS, in memory management. Then after that, we discussed on various techniques. And we say we have paging. We have demand paging. Then we said we have segmentation. And this is where we discussed on implementation. Then after that, we discussed on hardware organization. That is hardware and software organization. Hardware and software organization. And in this case, we said what we need to look at, programmed inputs through outputs, then event-driven or interrupt-driven. And if you look at what we're saying about this, we still said we need to look at what you call algorithms. And there are many algorithms that we discussed. One of them is first come, first serve. Maybe we have the shortest seek time. And then we have what you call least frequently used memory. Then we have optimal algorithm. So if you look at these algorithms, are the ones that are now assisting us to allocate processes in a memory and to allocate processes in the hardware. So in this case, we need first of all to interpret. So what I was saying is that we were able to look at these topics, and most of these topics that we discussed, if you look at the activities of an OS, it's what an operating system can do in an operating system, what an operating system can do in memory management. We look at techniques. That are mostly used within that. Then those techniques we discussed, one of them was called paging. And I think up to now, you know what are the functions, or maybe how to implement paging and how to implement segmentation, maybe how to implement even partitioning. At least now you can be able to understand on what we said on these algorithms that we have. Then after that, we said we can look at now the hardware organization. And when you look at the hardware and software organization, we are looking at the programmed input-output interrupt-driven. So in this case, we need to understand how the programmed input and interrupt-driven work within a given point. And there is a topic that we are supposed to discuss mostly in hardware. We are supposed to discuss it in hardware. That's why I want first of all to do away with it in memory management. Then the next one that we discussed was algorithms, and we say the first one is first come, first serve, and how they are supposed to be implemented in that. So what I want us to do is first
Thank you.
Okay, sorry. I was trying to connect internet. Hope now you can hear me.
Yeah.
Am I clear now? So I had some issues with an internet. Am I clear, Joshua?
Yes.
Okay, so I'm sorry for that. So what I was saying, if you look at the last topic we were discussing on various algorithms, and these are the algorithms that will now allow us to use those disks that we were supposed to allocate processes inside them. And that's why the next topic that we're supposed to discuss, if you look at the objective that we had on the introduction, I said we need to look at device management. And in device management, in this case, we are looking at which are these devices supposed to use. Can we use them the moment we are using them? So in this case, we will be able to look at various devices. And most of these devices that you'll be able to look at, one of them is what you call the input devices. Then we look at what you call the output devices. Maybe we can still look at what you call the storage devices. So that now we can be able to understand how should we use these devices to store data. How are these devices implemented? Or how are these devices structured? So in this case, that's why we need to understand that there are various principles. So we look at principles that we should use in order to make sure that now these devices are organized the way they are supposed to be organized. And one of the principles we look at is what you call security. Maybe you look at organization and physical organization. So to start with, I have posted the notes, and if you look at the notes that we have, I have already posted most of the topics that we are supposed to cover. And let us start immediately with device management. And when we understand about device management, we always understand device as a means of communication or a means of storage, because you can use it to communicate. Maybe the moment you are sending characters from one point to another, we use some communication. And this communication is either in form of characters, either it is in form of blocks, either it is in form of files or in form of records. So in this concern, that's why we understand that one objective of an OS is to always make sure that there is efficiency, there is efficient device use. There is efficient device use, meaning the moment we are using a device, we are using it the way it is supposed to be used. Then we should be able to look at now, the next one is to observe what you call security. So you must make sure that there is security in this device. And security is always provided by either read stroke write operation. Read stroke write operation. So in this case is where we understand that when you're using a disk, or maybe when you're using a flash disk, you are trying to copy a data, but it tells you cannot copy. So in that case, there is what you call the restriction, which has already been provided within the device. And if you look at this object, because we must make sure that the devices are efficient, the devices are secure, or we can have data that is secured in those devices. That's why we understand that most of the functions of an OS is, one, to make sure that there is what you call keeping track. So you keep track of devices. Now, which device is supposed to access the other? When you're using a keyboard, maybe if I am using an input device, and in this case, I'm using a keyboard. When I'm using a keyboard, we must understand that when you're writing, which keys are we using for writing? And what can we use in writing? So that is now the concern that we are supposed to have within here. So we look keeping track which devices is in the session, or which has been removed from the session, or which is supposed to be used in the execution. So if those devices are able now to execute the way they are supposed to execute, the operating system has already made sure that now everything has been successfully executed. The next one that we're supposed to look at is mostly where we can be able to understand there is efficient use. Efficient use. So are we able to use this device? We are using it as a keyboard, but is it working as a keyboard? Or maybe we are acting as another device. And when this device is not able to work as it's required, now we have not successfully done one of the objectives that we have done here. We have not done what you call efficiency within the device. And that's why we always look at most of these devices. We can go to look at now, is this device working as it's required? Is it working as an input device, or is it working as an output device? So efficient use in that. So the next one that we can look at is what you can look at discharging. Maybe you can look at discharging in and out, in and out. So we are looking at now moving the device and allowing the device to be used to access. Meaning, the time that you require a keyboard, now it must be allocated for use. The moment you're using a mouse, it must be allocated for use. So in this case, now we are looking at now using it as an input, or using it to be using it for a given purpose, and removing it within the allocations. So if we can look at these functions of an operating system in device management, now it becomes clear that most of these devices, they must be structured in a manner that's supposed to be efficiently used. It must be structured in a manner that it is very easy for you to keep track of the device that we have. So in this case, that's why we need to look at the principles used in device management. So in this case, we are looking at now the design. We are looking at the design of this device. How will you design this device? And that is why one of the principles that we are supposed to look at in this case, we can look at what you call logical organization. And when you look at the logical organization, if this is a device, maybe if I can use a paint, if this is a device that we are using, and we need to use this as a device, we need to use this as a device, and these are the allocation that we are supposed to have. So in this case, how will you be able to allocate the processes inside here? So this is what you call the logical organization. We now see that this is a 2 GB disk. The whole of this now forms what you call the physical. It forms what you call the physical. But the way we organize data inside the physical is what you call the logical organization. So in this case, we understand that we are supposed to have what you call the physical organization. So the moment you are designing an input device, that's why we can look at now, there is a disk of 2 GB, there's a disk that is supposed to take 2 characters, or maybe is supposed to take a speed of 2, or maybe this is supposed to take a capacity of 200 MB. And within that, you can be able to look at now, this is how it has already been organized outside. But what about now inside when you want to use it for data? Then the next one that you can look at is what you call the uniform treatment of devices. When you are organizing these devices, we should not look at now a device. We should look at as a device at its own interpretation. Meaning that if you have a device like E, like now, the moment I go to maybe PC, and we are assuming that if I go to PC, and we assume these are the devices that we are having here. I want to use a very clear one so that now we can be able to. So if you look at this, so if you look at these devices are treated as one device. So we don't have device A, device B, device C. We treat them as one device. But where we have some differences is where we have what you call the character presentation. So character presentation. Character presentation. Because when you treat the device, all devices are treated equally. We should not have a superior device than the other. So most of these devices that we are using, they are supposed to be the same. And if these devices are the same, now whatever is different is the character presentation. So the moment you are using these principles, for you to come up with a design, it's like now I'm designing an input device, but I need to look at now the structure of those people who will be using the device. Maybe I have a keyboard. Like now, if you look at a keyboard on your mobile phone, it's too small, but within your feet. So it is not too large, it is minimal in that case. So in this case, we are looking on how we can process this. So character presentation is catered through speed, and that's why we understand that if you look at most of the devices that you always have, you have to consider speed as a determinant, which in all time we must look at as one of the aspects that we should be able to have within these devices that we have. Then the next one is what you call permissibility. Permissible or permissibility. Permissible, we are looking at now either reading data, stroke writing. When you are writing this, are you able to write it as a block? Or are we supposed to write it as a character? Or are we supposed to write it as a file? So when I'm using a printer, mostly a printer uses character presentation, because when I'm printing a document using a printer, first of all, it must read data. Then it must organize in groups, maybe. Then after that, maybe it can do what you call printing. So these are transitions, what it can do. So first of all, you are reading the data, you organize the information, then after that, you print that information. In this case, that's why it uses what you call a process called pooling. That is what we can define as sequential way of organizing data. So in this concern, we are looking at a point where most of these devices are they able to perform these operations. And it is performing what you call the read operation. It is performing what you call the organizing in and out operations. Maybe it is doing what you call the printing organization, which now are organized into a sequential way that you can be able to use in the execution. So if these devices are able now to be organized in that manner, that's why we need to ask ourselves, when do we start organizing these devices? And when we start organizing these devices, because if you look at these notes that we have here, we are saying most of these devices, the use is what you call pooling. And within this pooling, they must be organized into a given structure. And this structure that we are supposed to organize them, we need to start from what you call the input-output management, input-output devices. So these are the operations, or these are the way they are categorized, where we categorize them as either human readable, machine readable, or communication. So you can read data, either it is machine, if it is human readable, there is when the human can read data. So when you are coming up with that structure, you must understand that the principle is about reading data. That's why we have talked about reading data here within the case. Then machine readable, is this device able to sense? Like now we have like sensors, controllers, and then we have actuators in our systems that we use. Maybe you use communication to move from one point to another. So in this case, that's why I want us maybe to look at what you call the input-output structure. At the moment we look at the input-output structure, we must always be able to observe where should we start. That's why we have device controller. So in the first case, allow me to use this page. So we call it structure of input/output devices. So in this case, we can look at a point where maybe we can insert for a clear presentation on this. Allow me to clear this, and I hope you can hear that. So in this case, we always start with the input/output. We start with applications, sorry. We start with applications. Then from applications, we go to input/output control. Then from there, we can go to what you call the device drivers. Then from device drivers, we have the device controller. Then from device controller, the next one that we are supposed to have is what you call devices. So in this case, if we can look at those 5 structures or 5 sections of a device structure. Now we need to ask yourself, what should we have in order to present this data? So, okay, I want to delete these columns and I be left with this. So if you look at these structures that we are having here, the application is where we have programs. And these are the programs that are mostly used for execution. They're used for execution. So you allow the device to execute. So this is where now you can use something like maybe one application device, maybe you can use other programs that we have so that we can be able to communicate with users. Maybe we can use like operating system, maybe we can programming languages, etc. But in this case, we need to look at which device to use. Now, e.g., maybe I'm using a keyboard. And when I'm using a keyboard, I have to ask myself, is this device recognized in the input-output management? Because if you look at now, the interpretation of management is controlling, organizing devices in the execution. So you must understand which are these devices we are having. Now, I'm using a keyboard. Is this keyboard accepted within the communication? That's why within here, so in this case, you find that these are softwares. So here we have what you call softwares. But here, we must use what you call hardwares. And in this case, because now we must try to look at whether we have the right device that we're supposed to use. So these are devices these are softwares that update other softwares or hardwares. They update other softwares or hardware. Like now, when I slot in a device, maybe I'm using the connection of this device. I remove. When I insert this, there must be a pop-up message. And if you look at the pop-up message that we have here, it says USB device not recognized. Now, the question that you're supposed to ask yourself is, who now gives this output device? So it has been updated and it has been recognized that this device is supposed to be recognized. That's why it can be able to tell you that this device is not recognized, because it is acceptable. But the problem is the software is not updated. Maybe you have an issue with the hardware. Maybe the cable itself has an issue. Maybe you have another issue that we are having within maybe an application. Maybe the operating system has a problem. So device drivers are mostly used to update softwares or hardwares. Then we have device controller. And I want to look at this device controller in various ways. And one way is doing what you call mapping of faults. Mapping of faults. The next one that I want to look at is to accept read stroke write. So you ensure, that is ensuring read and write operation is made within. So that's why we find that when you install an operating system, the first thing that is installed is what you call, maybe I can write it here, is what you call Windows Explorer. So we install what you call the Windows Explorer. Windows Explorer. Remember that we have Windows Explorer and we have Internet Explorer. So Windows Explorer are the ones that are now creating the interface that we see. This interface that we can be able to see, that we can allow the user to use it, which is now controlled by the device controller. So the device controller controls whether the has been certified, whether there are some faults within the devices, and if there are some faults within the devices, now we can do away with the execution. Now, that's why sometimes you find that now, if your device tells you the msconfig file, the msconfig file has an issue, this file means that the operating system cannot start. That's why, because the device controller has already accepted that the input, the application that we are supposed to have, or the executable file that we are supposed to have for an operating system is not able to work as it's required. So that's why we look at some various issues here. Is the device controller working? If the device controller is working, now you have to look at that. Now, maybe if you come to your search button and maybe you try to look at device controller, I don't know whether it will be able to pop up. Device controllers. So if you look at the device, so these are the device managers that are supposed to have within a computer that are able now to make sure that everything is working as it's required. So within the execution, so they control all these operations that we have. So mostly the device, if the device controller is working now, automatically now the devices intervenes. And these devices that we talk about is input stroke output devices. Maybe we can have storage devices, etc. And I think up to now, if you understand about the input and output devices, we all understand that concept of input and output devices in that. So that is just an explanation of what we expect, just a few explanations of what we expect within the hardware devices. And that is now why, if you move away from this interpretation of hardware structure and a software structure, now we need to look at now maybe the hardware and software organization. But before we continue, I want maybe to get a question from you. Is there any question that you have before we proceed? Komodi, do you have any question?
I have a question about principles used in device management.
Okay.
So how many are they? Is character one, presentation one of them?
Yes, it is. So what we have said is that
Yeah.
one of them is logical organization.
Yeah.
The next one is what we call physical organization,
Yeah.
uniform treatment of devices, and character presentation. Sometimes in most of the book it is called character independence. Character independence. So like now, if you look at the time that you are executing devices, each and every device has its own execution. One is processing A, the other one is processing B, the other one is processing D. So if you look at now the device, they have their own character presentation or character independency within that.
Okay, and what about permissible? What is it?
Permissible, okay. When you talk about, there is permissible. I'm sorry for that if I've not, okay.
Yeah.
So if you look at this, we look at permissible. So you have one, we have two, then we have three, we have four, and the next one we have five. Meaning that permissible, how is the device or how the device is supposed to read and write data? Is it supposed to read it in terms of block, in terms of character, etc.? So if you look at maybe a printer uses character. If you look at a monitor uses character. But what you can see, we are seeing everything at once, but we print character by character. Okay. Are we together up to that point?
Yeah.
Yes, that is now why we are saying when you are designing, it's like when you are building a house, there is something that there are some things that you need to consider. One, you need to look at the scalability of this house. If you are building a house that maybe will be able to accommodate more people, maybe you look at sitting room should be big. Maybe if you look at bedroom should be maybe a given length and width. So in this case, you don't build a house before you look at what you need to have. So in this same case, when you're designing an input-output device, you need to look at now how will it process data inside? How will it be organized? How will I treat them? I don't want to insert a disk, then after that it tells me we still have it. That's why you now insert a disk and it tells you you can create it or you can have another name. Character independence, every device that you have, it has its own execution. We cannot say device A is executing the same way device B is executing. So that is now something that is not good, because when you say device A should execute A and device B should execute B and nothing else, that is limiting the executions. So that is why we need to look at these principles that we have. And that's why we have said these principles will allow us now to come up with the structure in these devices. Because we cannot say we are having logical organization if you don't know which applications are supposed to be used by these devices. That's when I use a keyboard with any application. I can use it either in a operating system Linux, Kali Linux, CentOS, Red Hat, Fedora, and many other applications that I have, but doesn't control. This device can be used at any point. We don't have any issue. This device has to be updated. I think this is not new. And sometimes when you're trying to execute, it tells you the device is not recognized. That means the issue is on device driver. And that's why if you go to the device manager, here, there is, maybe I click one of the device, maybe I click this device driver, this. If I try to right click, one, uninstall device, update drivers. So when I say maybe update drivers, if you look at maybe the properties, the device is working properly. But we can see maybe how it has been organized here. But our case is not there. So we are looking at now, is this device updated? That's why you find that most of the devices that are not updated in the system, they have some question mark. Like now, if you look at this, which has an exclamation mark, it means this device is not recognized. So even if I insert this, maybe if I try to right click, Windows has stopped his device because it has reported problems. So this is not a right device. So you need to update the drivers for it to access. That's why we find that most of the devices, maybe we can look at whether we have a question mark somewhere. For my computer, we don't have a question mark. So if you try to expand these are the ones that you are supposed to update if we have some issues, so that we can now launch the execution. So that's why we are saying device driver is a software. It's a software that updates software or hardware that are supposed to be. Like now, when you're using your computer, like now if you install Windows 7, automatically Windows 7 doesn't accept drivers. You have to install using Service Pack. Maybe I can use maybe Service Pack what? Maybe I can use Service Pack 13. Maybe I can use 10, Service Pack 10, so that I can be able to update these drivers. Because now the hardwares are not able to communicate. But whatever has to be used, if I go to run and I use run, and I write msconfig. If I try to click msconfig, now this msconfig is now a startup data. So if the device controller is not working, it will never allow me to come to this setup where I can use either normal startup or I can use save mode in the execution if I want to use boot. In this case, if you look at the operating system that I am having, the device controller is 100% working because it can allow creating of the platform. And I think, I don't know whether this one will work. Maybe if I write Windows Explorer. So I want to, let me search over the internet so that we can see. So can you see the function of a device controller is to allow to make sure that this view is applicable. So this view. So if I come to this, it is now giving you this platform. So if it is giving you platform, it means the platform that is giving you is this. This is the platform that is giving. So this platform is given by what you call the Windows Explorer. That's why we find that now there are some cases when you are trying to execute some jobs, it always have some issues if the Windows Explorer is not working. If the Windows Explorer is not working, we still have some issues in the execution. And we can now resort to some issues. And I think if you try to go to all programs that are running, if I right click maybe on a PC, if I go on a PC and I right click, then I go to manage. Don't know whether that one will delay us. So you can look at the device manager. So we look at the device performance. So in this case, we can maybe create on that. So that's why we find that all these are the applications that are running that has been accepted by the Windows Explorer. And these applications that are running currently, which has already been accepted by the device controller, and that's why if you try to expand this has been expanded. And if you try to look at this, we can see Explorer somewhere. Okay, there is Explorer somewhere there. So this is the Explorer, which is creating this platform for this execution. If you look at this, I don't know whether we have Explorer. We still have Explorer here. If you look at the internet, we must have Explorer. For this one, we don't have an Explorer that is running because we are not frequently using the network that has been provided within the execution on that. So for this execution, we must have Explorers, which is able now to create a platform for that. And that's why all these are jobs that are supposed to be used in the execution. And when they are executing, they are given the platform to execute by what you call the Windows Explorer. So that's why if I say the CPU should not remain idle, that's why we see the CPU is always running with a multiple of jobs, with presentation of various jobs in the execution. In that. So that's why we need to understand that device controller does a lot of work. Mapping of any faults that might arise within the execution, allowing read and write within the operations, making sure that now the tracks and sectors are met within the execution, making sure that everything, so efficiency within that is given out. Then if you look at now the devices, that's why we have said we can now use input device. Then we use output device. And within this, we'll be able to understand that device has a lot to do within the execution. Has a lot to do within the execution. So I want to pause there first. And if there is a question, maybe you can ask before we proceed. So any question?
No.
Do you have any question, Amodi?
No.
Okay, Gomia. I hope Gomia ako class. Gomia, are we together? Do you have any question, Gomia, please?
I'm asking what the function of the Windows Explorer.
Okay, the functions of
Windows Explorer.
So the functions of a Windows Explorer is mostly to create the platform for other applications to work. Yeah, to create a platform for other applications to work. We still say it creates an interface. It allows creation of interface within an operating system. That's why I've said it creates this interface. Yeah. It allows this interface to be created. It allows this interface to be created. Where now I can work with operating system. Because if the Windows Explorer is not there, automatically we have some issues within the execution. Are you getting now?
Yeah.
Yes. So for this case, that's why we need to look at a way of organizing hardware. How do you organize hardware? So we look at hardware and software organization. And in hardware and software organization, so hardware and software organization. So we look at now, one, we need to look at what you call input, output, input, output control. And the next one is what you call the programmed input stroke output. Then the next one that we are supposed to have is what you call the direct memory access. Sometimes we call it DMA. We call it DMA. Then the next one that we are supposed to look at is what you call interrupt driven. Interrupt driven. So if you look at these, they assist in hardware organization. So we say these are functions. So we are saying these are the functions. How should the device work? They should have input-output control, controlling all the devices that are supposed to be used in the execution. Then for this case, we are controlling how the devices are supposed to execute. I want to present something here, maybe using Paint. Let me use Paint. Paint. We always understand in an execution, we always have what you call CPU. We always have what you call CPU. So this one we can call it CPU. Then this, we can call it input stroke output module. So input stroke output modules. Then if you look at this, they should be able to communicate to what you call now the devices that you are looking at. So this is where we have the physical. So if the handwriting is not clear, I think you can hear physical. Physical. So in this case, this is where we are looking at either RAM and any other devices that we have. But within here, we can have what you call buffers. We can have buffers. And buffers are storage that are mostly used to store data. They are supposed to store devices that can be used in the execution. So in this case, if you look at most of the execution that we are having, so any question up to that point? So if you have a question, you can ask there.
So buffers refer to storage to store data.
Sorry, if you have a question, can you ask? Yes, can I? Yes, ask again, please. Yes, Joshua.
Gomez, down was a question.
Okay, who has asked a question? I have not heard clearly, please.
I was asking
Yes.
about buffers.
Yes.
It's saying that it stores data.
It not stores data, but mostly it stores the devices that can be used in the execution. Devices that can be used in the execution. Right now, if you look at most of the devices, there are sometimes you are using a keyboard, and there is a time that you are not using a keyboard. So when you are using a keyboard, and the moment you are using, when you are using a keyboard and you are not using a monitor, maybe let me use that as an example. Monitor is stored in a buffer temporarily, awaiting for any response from the CPU. So we can say buffers are mostly used to temporarily store devices that can be used in the execution or that can be used during execution. Is that clear now?
Yes.
Yes. Any other question?
No.
Okay, so what I'm saying is if you look at this diagram that I have drawn here, we can assure that processes are supposed to execute inside the CPU. So there is where processes are supposed to execute. Suppose we have a process here, or we have a job. Suppose we have a process here, or we have a job. And this process or the job that we have requests an input device. When it requests for an input device, the CPU now is the one that is supposed to request on behalf of a process. So a process will never be given an input-output device if a CPU is not given the high right of what is supposed to be given, or it cannot be given by any other. So what we are saying is that in this case, if the CPU is now requesting an input device, and the CPU leaves back its current job that it was doing, so that now it can request for an input device. That is what you call a programmed input-output. Meaning, the CPU requests for an input device. When it requests for an input device, when a device is granted, the CPU goes back to do his job. So it doesn't care whether the device has been given to the process or not. But what it cares, the device has already requested an input device, but it doesn't care whether it has been accepted by a process. But the moment you talk about interrupt-driven, we are saying if the CPU requests for a device, the CPU waits. The CPU waits for this process to complete the execution. And when it waits until the process completes the execution, that is the time it goes back to its normal job. Remember, the CPU is not idle. We said the CPU should always execute. So if it was requesting for these devices, and it was requesting and it was given, and it goes back to its core jobs, that is what you call programmed. But if it waits for the process to complete the execution with that device, that means that is what you call the interrupt driven. So if you can try to compare these two, interrupt driven and programmed input, we are saying this one, it doesn't care whether the device has executed or not. This one cares whether the device has executed. So in this case, we have efficiency. Here we have speed of execution, but here we reduce the speed in execution. Have you understood? Yes?
Where do we have the speed? In the program or interrupt driven?
The device, the way the device are able to interact with the processing is now the speed. That is where the speed is. So if the device can request, or if the CPU can request a device and it goes back to its normal processing, it means now the speed is too high in the execution. But if the CPU can request for an input-output device, but it doesn't, it waits for this process to execute, speed reduces, but it is more efficient. Are we getting that?
Yeah.
Yes. So that is the case where we are saying most of these, they assist in execution of devices. When are we supposed to use device? But now the moment we are looking at direct memory. In direct memory, they resort to what you call cycle steering. They resort to what you call cycle steering. And in this case is where we are saying if the device can communicate directly with the physical memory. Now, communicating directly, instead of now passing through the CPU, we know that the rule is we must pass the CPU. But if we are not supposed to pass to the CPU, if the input-output device is able to communicate directly with the memory, that is when we are saying it is direct memory access, meaning this memory has already requested the CPU. Can I use the input-output device? It has been granted to it. But irrespective of any, we are not considering the efficiency. Because now if you consider the efficiency, it means that now we will issue some problem here. And when we issue some process here in the execution, now we will not have a very good way of execution. So that's why we are saying direct memory access is when the input devices, that is input-output devices, are able to communicate with the memory. They are able to communicate directly with the memory. So if they can be able to communicate directly with the memory, that is when we are saying we are using what you call the input-output devices in that execution. So we can look at that aspect and we say it is doing what you call cycle steering. So cycle steering is as a respect of a process is not following the procedure of execution. It is not following the procedure of execution. And if it is not following the procedure of execution, we always resort to those issues of efficiency because we don't have efficiency in that execution. So in this case, we have looked at a point where devices are organized in a manner they can be able to introduce devices that can be able to communicate. They can introduce the devices that can be able to communicate with the CPU without waiting for the execution of those jobs. And they can resort to what you call the cycle steering of these processes that we have, or they can interrupt, waiting for a process to complete the execution. So out of this, that is when we need to look at now what you call the disks. The disks. So the next topic that we are supposed to discuss here is what you call the disks. the disks. Which are these disks? I want to talk about the hard disks. I want to talk about the hard disk because the hard disk is the one that we use mostly when you are referring to an operating system. Mostly when you are referring to an operating system. And that is why we need to talk much on disks. Then within this, we still look at now the algorithms. The algorithms used within the storage. So we look at the algorithm used within the storage and why do we need to use a disk in that aspect. So I want you to ask a question before we proceed to this subtopic called disks. Today's subtopic called disks. Is there any question up to that point?
No.
Any question?
No.
So for this case, I don't want to go beyond that point. Let us first of all understand those subtopics that we have already discussed for now. But I want us, before we maybe end this lesson, and remember we are supposed to go to the chat room, we chat. I will give you some questions that you're supposed to do. Please do them. I'm recording them. Remember, even if we go back tomorrow, I will still start from disks. I cannot start from maybe the last topic that we discussed last week. I will start from disks. Are we together? So it is good. So tell your friend to come to class because I have seen they have been registered. Tell your friends to come to class. We are remaining with one topic, and I'm assuming that towards the end of completion of the last topic, we need now to flashback what we did when we are away, the moment we resume back. So in this case, I want us to go to the quiz. We do a quiz, a very short quiz. Then from that quiz, we will be able to create a chat room so that now we can answer some questions. Any question, either from the memory that is not clear on you. So please don't move away from the communication. Are we together?
Okay.
Yes, it's good we communicate because still, remember, communication, chat rooms are still recorded. And because they are still recorded, they give you grade. Any attempt that you do, you are given 1 mark. So please attend and remember, these are the marks that you are supposed to send to NEC. Remember, what I'm giving to you at this time, it will boost your grade. So that's why I'm telling you to make sure that you be in class up to the last time. That is up to 5. Are we together?
Okay.
So is there any question? I want to give you an overview of what we are supposed to discuss on these disks. Are we in the same page?
Yeah.
So when you look at the disks, what you'll be looking at, we will be looking at some few terms here. One, we will be looking at why are we having a hard disk, not a CD. I don't want to do some calculations here where we can say maybe we are using a CD and we are using a hard disk. So if I can use an external hard disk in terms of cost, and I want to use 1 TB here, 1 terabyte, and here I know that mostly they go up to 700 MB. So if you look at this in the market, it is costing 30 bob. Let me use that bob. But if you look at this TB, it's costing 6,000. And I think it is not, it is a fair cost. 1 TB, 6,000. So if you look at this, you need to look at why are we using a hard disk instead of a CD. One is about quality. Second is about speed. Then maybe you can look at the cost. Maybe the next one we can look at the efficiency within the storage. So if these are the factors that you are looking, if you are looking at 1 GB, so 1 GB is costing 6 bob. So what about this? So if 1,000, if that 1,000 MB cost, if 1,000 MB is the one that now resort to what you call 1 GB, so we are saying, what about 700? So it is 700 over 1,000.
1,000.
So this means we are having 0.7 GB. 0.7 GB. So if 1 GB or if 700, if I can use that, the one that I have, or if 0.7 GB cost 30 bob, because we have already converted that. What about 1 GB? So it is 30 times 1 over 0.7. So we are now saying, if I can use calculator here, it is like we are saying 30 divided by 0, maybe 0.7, which is resulting to 42. So we are saying if you are using a disk, maybe if you are using a CD 1 GB is supposed to cost 42 bob. That is CD. But if it is a hard disk, it is supposed to cost 6 bob. So if you look at this, we cannot determine this as a cost. We cannot use cost to determine what we should use. At least we can use quality. We can use the speed. Cost is not efficiency. Efficiency, how can you measure efficiency? So for you to measure efficiency, we need to look at maybe the vendors. This is Samsung, maybe this is HP, etc. So you look at that quality. So in this case, if you are using this simple calculation, cost is not a determinant in disks. So we need to look at that. So in this case, one can be speed. How can you measure speed? One, you can use seek time. You can use what you call mean time to failure. Then the next one, we can use what you call the latency delay. The latency delay. So if you use those aspects, we can say the seek time is the time that you take to access a certain disk. Right now, if I'm using maybe Notepad on this, if you look at most of the disks are made up of sectors and tracks. So we can say this is the first one. Maybe we can see another one. So we always use piles of disks. So in this case, we can say these small circles that we are having are the ones that we are forming what you call tracks. So the whole of this forms what you call a track. But the moment I try to divide this into sections, so the whole of this now becomes a sector. So for you to combine these tracks and this track, so we use what you call a seriator. We use what you call a seriator. When you combine that, remember that you must read. So how are we supposed to read? You read and you read another. So here we have the read, stroke, write, the head. The next one, the same case. So it is at the top and at the bottom. So in this case, we are moving in and out. So the moment I position the reading head here, now that is what we are calling the seek time. The latency is the time that I start moving the disk. So when I start from here, now to move from here, the time that I take from here up to here, that is the latency. So when I'm moving from this point up to this move, this is the latency. Seek time is when I position the head. That is the seek time. Mean time to failure is when you look at now, for how long can you work with this disk without failure? For how long can you work with this disk without failure? Maybe I can work with 2 hours, I can work with 2 years, I can work with 3 minutes. So in this case, I'm looking at mean time to failure. And all of these are controlled by the disk controller. The disk controller. So the disk controller is the one that always makes sure that everything is controlled in a manner that is accessible. So if you look at this execution, we will be able now to determine that these devices or disks that we are using, they are up to date in the execution. That's why we will be able to go to our notes and be able to talk about this disk storage. And the one storage you'll be able to look at is RAID memory. Maybe we can use the disk as secondary storage. And that's why we need to start from this, what we are calling algorithms, disk algorithms. So this question is examinable in EC. So make sure that you understand this question. We will do it systematically, one after the other. Then when you come back, we still repeat it, because I know sometimes it's confusing. And we need to look at now, how are we supposed to read this? Using FastCam, using seek method, using scan, using cscan, using look, using clook, etc. All these are algorithms that we'll be able to discuss. And after we discuss this, the next topic that we are supposed to discuss is what you call clocks. And when you discuss clocks and terminals, that will be our end of what we are supposed to discuss at that point. So for now, allow me, we go back to our chat room so that now we can have some questions that we can be able to answer at that time. Do you have any question up to that point? Any question? Omodi?
No.
Come here.
No.
Okay, so can we go to the chat room now? And thank you for that. Let's go to the chat room. We do a question. There is a question that you are supposed to do. So there is a cut that you are supposed to do, cut 1. We are supposed to do cut 1, where I wanted us to do that cut today, but we had an issue with the system. Is it possible we do it on Friday in the afternoon?
This Friday.
This Friday, yes. Remember, this is the timeline that has been given by the university. If you fail to do that, it is very hard for us to do in another day, because now the system can reject all that. So can we do it on Friday? On Friday, do we have a class in the afternoon? Or at 11? Do you have a class at 11?
Yeah.
So,
Yes.
so when can we do? Friday, or at what time?
In the afternoon.
In the afternoon from 2, eh?
Yeah.
Yes, let us do it on Friday from 2. Thank you. Let us meet in the chat room.